Hi all, welcome to the 1.6 video. You should be on pages 19 and 20 in the green packet. Section 1.6 is all about classifying polygons. So looking at our objective, today we will be classifying polygons in two ways. First by their sides, and then by their angles. So we're going to start with the vocabulary. First, we need to write down the four properties of a polygon. So before we can even classify a polygon, we need to know what a polygon is. First property of a polygon lies in a plane. And remember that a plane is just like a flat piece of paper. It's two-dimensional. So a polygon is two-dimensional. A polygon is always a closed figure. Okay, a polygon is formed by line segments. And line segments are always straight. So in other words, this is saying a polygon does not have curves. So a circle is not a polygon because it has curves. And then the last property is that each side intersects exactly two sides. So each side intersects exactly two sides. And we're going to see a few examples where that is not the case, so we can see that property more clearly. The vertex. A vertex is just the end point of a side. So if I draw myself some polygon here, this right here is the vertex. It's the end point of a side. Here's another vertex, there's another one, there's another one. Okay, convex we're going to skip for right now. Convex and concave go together. Concave means that the figure caves in on itself. So an example would be something like this. This part right here is where the figure caves in. It bends inward. It bends towards the middle. A convex figure is just not concave. So it does not cave in. So this figure that I drew first, this one here, this is convex. None of the vertices cave in towards the middle, so it's convex. Okay, so moving on to example 1. We are going to do A and B together, and then you're going to do C and D. So first it says, determine whether the following figures are convex or concave. In order to be convex or concave, the figure has to be a polygon. So let's look at A. Sorry, I'm going to move this one more time so hopefully we can see those properties. Okay, figure A, does this lie in a plane? Yes. Okay, is it closed? Yes, there's no open space. Is it formed by line segments? Yes, there's no curves. Does each side intersect exactly two sides? Well, let's take a look at this side. This side right here intersects this side, and that side. It intersects three sides. So this is not a polygon. Okay, B, lies in a plane, yes. Yes, it's a closed figure. Yes, it's formed by line segments. And yes, each side intersects exactly two sides. So yes, this is a polygon. Now we need to determine, is this convex or concave? Well, does it look like any of the vertices are caving in towards the middle? No, so it's not concave. So B is going to be convex. Okay, you take a minute right now, pause the video, try C and D on your own, please. When you are finished, come back and we'll go over it together. Okay, so hopefully you took a minute to try this one on your own. C you should have gotten is not a polygon. That's because we have this curve right there. D is a polygon. It's a concave polygon. You'll see these four spots where the polygon looks like it's caving in on itself, where it's bending towards the middle. So hopefully you got those right. If not, please jot down any questions you have so that you can ask them in class tomorrow. This table at the bottom is just kind of a quick review for you. So any figure that has three sides is called a triangle. Any figure that has four sides is called a quadrilateral. So special quadrilaterals are squares, rectangles, parallelograms, but in general, if a figure has 4 sides, it's called a quadrilateral. So you should know 5, 6, 7, 8, 9, 10 is called a decagon, 12 is called a dodecagon, so we just add that do part. Anything above 12, so say a figure has 13 sides, we call it 13 sides, it's called a 13gon. 15 sides, it's called a 15gon. 70 sides is called a 70gon. So anything past 12, we don't really have any special terms for anymore. So that's what this line is telling you. Okay, so that's page 19. Right now, I would like you to flip to page 20. Okay, so we have a few more definitions that we need to write down. Equilateral is when a figure has all sides congruent. So that's where the lateral comes from. All the sides are congruent. Equiangular means all the angles are congruent. All the angles are congruent, so all the angles are the same. And a regular polygon is a convex polygon. So it can't be concave, it can't have any parts caving in. It's convex, it's equilateral, and it's equiangular. So convex, there's nothing caving in, all the sides are congruent, all the angles are congruent. So looking at example 2, we're going to do A together. You all are going to do B and C on your own. Looking at A, it says classify the polygon by number of sides. Okay, so looking at the tick marks, I have 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. And then it says tell whether the polygon is equilateral, equiangular, or regular. Okay, is the figure equilateral? Yes, all the sides are congruent. The way I can tell that is with these tick marks. All sides congruent. Okay, is it equiangular? Yes. These arcs mean all the angles are congruent. Okay, it's equilateral, it's equiangular. Is it regular? In order to be regular, the figure has to be convex. This hexagon does not have any parts that are caving inwards. So yes, this figure is convex. That makes this a regular hexagon. So it's convex, it's equilateral, and it's equiangular. Right now, pause the video and try B and C on your own, please. Write something down. When you are finished, come back and we'll go over it together. Okay, for B, first this is 4 sides, so this is a quadrilateral. Okay, it's not equilateral because we have 2 tick marks and then we have 1 and 1, so all 4 sides are not congruent. It's not equiangular because again we have 1 arc and then we have 2 arcs, so not all the angles are congruent. Because it's not equilateral and it's not equiangular, it cannot be regular. So it's just a quadrilateral. That's it. Looking at C, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. So that would make this a dodecagon. Okay, it's equilateral. Yes, it's equiangular. Yes, it is not convex though. We have these 4 parts right here that are caving in towards the center. This is not convex, so the figure cannot be regular. Therefore, it is equilateral and equiangular. Sorry, I ran out of room. So hopefully we got those 2 right. We have 2 more examples to do and then we are finished. So example 3, it says the expressions 9x plus 5 and 11x minus 25 represent the measures of 2 angles of a regular nonagon. Find the measure of one of the angles. Okay, so what's really important is that we are told this is a regular nonagon. So regular means it's convex, it's equilateral, and then most importantly in this case is that it's equiangular. So the angles are congruent. That means these 2 angles are going to be congruent. If they're congruent, I can set them equal to each other. So I have 9x plus 5 is equal to 11x minus 25. Subtracting 9x, I get 2x minus 25 is equal to 5. If I add 25 to both sides, I get 30 equals 2x, and x equals 15. Now, the question asks us specifically, find the measure of one of the angles. So what I need to do now is I need to substitute it in. So 9 multiplied by 15 add 5 is going to give me 140 degrees. As you guys know at this point, I really like to check my answer. So I'm going to substitute 15 into the other angle as well. If I do 11 multiplied by 15 and I subtract 25, I get 140. And that should be the case because our figure is equiangular. Our angles should be congruent. So final answer is 140 degrees. Last example you have to do is example 4. Pause the video, try this one on your own, and come back when you are finished, please. Okay, hopefully you took a chance to try this one on your own. Because we have a regular quadrilateral, we know that the sides are going to be congruent. It's going to be equilateral. So you should have done x squared add x is equal to x squared add 4. If I subtract x squared from both sides, these x squareds become 0, these x squareds become 0, and I just get x equals 4. That's it. Final answer. So hopefully we got that one right. If not, that one was a little tricky, and hopefully we'll get it right when we do it in class. So this whole video, this 1.6 video, has covered classifying polygons by sides and angles. Sides, we talked about the classification in terms of triangle, quadrilateral, pentagon. We also talked about convex and concave, and regular and equilateral and equiangular. For angles, we pretty much just talked about equiangular. So when you come to class, we will be working on some problems from this section. Thank you.